Here we are in week 3, Friday 4/3, day 13, finally. So what we're going to do today is we're going to go over the last section that we had to read. So first of all, I wanted to do is I want to kind of show you my what my ISM book looks like. I will try to post a picture of it sometime this weekend maybe for you to help you. But right now, what we're doing is we are here at this section right here on two-dimensional collisions. So, when they're talking about, we talked about yesterday, or whatever day you want to call it, it was really earlier today for me, we talked about two particle collisions, and now we're going to talk about two-dimension collisions. So here we have a ball, a billiard ball, and it's on a billiard table and it hits another ball. And there's two dimensions to that. It says after the collisions, both balls are moving and have momentum. PCI equals PCF plus DDF. So you have an Y and an X axis, and that's where you have the Y's, and there you have the X. Remember, Y and X has to do with dimensions. And then also, it also talked about a car collisions, and it gave you an example for that. That collision, that thing was on page number 250. And so on 250, it was talking about a 1,325 kilogram car. And A and C was moving north at 27 meters per second, collided with a 2165 kilogram car, D, and then moving east at 11 meters per second. The collision caused two cars to stick together and direct in which the speed does, what speed do they move after the collision. So the first thing they did was just draw the situation. Then they wrote down everything that they knew, and then they solved for the unknown. And then over here, do you see that? So when you see that, remember that has to do with angles, and we're doing angles we have to refer back to. So I marked it in my book. This was page 125 for me, which was vector components. You will need to look at these because this is going to tell you if you're going to use sine or cosine. Okay? And also this. So what I did is I just took a piece of paper and I marked it in my book on page 125 so I could go back to it when I'm doing the problems. Remember also in your calculator, when you are doing angles, you will have to go in here and you will change the mode to degree, remember? And also, if it's a small number or you think you're going to have an exponent, I personally would go ahead and change it to scientific 2 so that I would have it ready. So, what they did there is they just basically went through and showed you how to solve it, how to find the final speed. And now we're at question number 26. So it says here a 225 kilogram car was moving at 20.1 meters per second, colliding with the 1,865 kilogram car, moving west at 13.4 meters per second. It was asking after the collision, the two cars were stuck together in the direction at which the speed, what speed do they move after the collision to divine the system of the two cars. So here, what we're doing is, the first thing we're doing is we're taking the two masses of, we're taking the car moving and at what speed it was to get P1. And then when we get done with that, then we're going to go and we're going to take that number and then we're going to multiply it with MX and VIX. Then we're going to come over here and we're going to do for PF, we're going to do like PI, and we're doing the square root of this. So I want to kind of show you how to do that math. Now, first things first, is this an angle? It is not. So I want to go back. I want to go back, and I want to change mine to radian real quick so I can fix this, work on this problem. So it says square root, open bracket, negative 2.5 times 10 caret 4, close bracket, whoops, I got to go down, don't I? So then I want to go down close bracket, and then I'm going to square it because it tells me to square it. And then it tells me to add, and then open bracket, 1.86 times 10, caret 4 over close bracket, and I'm going to square that also. And that should give you 3.11 in E4, and I just rounded it to 3.112 times 10 to the 4th. So then the next one, once you get that done, then you're going to have to find your velocity final. So to be able to do that, you're going to do alpha y inner because it is a fraction, and you're going to do 3.12 times 10 caret 4, and you're going to go down, open bracket, 9.25 plus 1865, close bracket, over, and enter. And that's where I get my, let me change my mode to normal. And that's where I get my 11.2. But this here says that it is 11.2, but I got 16. So let's see what I did wrong. So when I'm looking at this, 3.12 times 10 to the 4th, and then I had to take 9.25 plus 1865. So let's do this first. 9.25 plus 1865 and hit enter. And then I'm going to take my Then I'm going to take my alpha y enter, and I'm going to take my 3.12 times 10 caret 4 down, second answer, enter. Try it again. Alpha y, alpha y, enter. 3.12 times 10 caret 4 down, and let's see if I can get my second answer again. And then I got 16 that time too. So I'm assuming, based on what I'm doing, I'm going to keep the 16.64. And I'm going to put a little mark beside it. And then I'm going to come back to it if I have time to check that again. So then what they're doing there is they're doing 10, -1. So let's change our mode back down to degree. And then what I'm going to do here is it says 10, -1. So tan -1 is blue tan. And then that's a fraction. Alpha y, enter. So I got 1.86 times 10 caret 4 down, -2.50 times 10 to the 4th power, over, close bracket, enter, and I get 36.6 degrees. So that one is 26. So let's look at 28. 28 says a 1345 kilogram car is going west at 15.7. So I'm doing the same thing again where I'm taking my mass times my velocity to get my P1X, okay? And strikes a car at 1,223 and sticks together and moves in a velocity of 14.5 at an angle of 63.5 degrees. What is the north moving car extended? So the first thing I'm going to do is I'm going to find this, and then I'm going to take my two masses and add them together, and I'm going to multiply that by my 14.5 to get this answer. Then what I'm going to do is then I'm going to take that answer, which is this right here, and multiply it by sine, and it tells me the angle is 63. So let's go ahead and do that. Open bracket, 4.74 times 10 caret 4 over, close bracket, and then I'm going to do a sine because it's not a negative. I'm just hitting sine. 63.5. Oh, did I change it to degrees yet? We'll see. Okay, let's do scientific notation. 4.24 times, and that's my answer, 4.24 times 10 to the 4th power. And there we are right there. So we are all good with that answer, but we are not done. Now what we have to do is we have to take that answer and divide it by our mass 2. So we're just going to do second answer, and then I'm going to just do a straight up 1923, and I get 2.20. So let's look back at this issue that we have. If you'll give me just a second, I'm going to push this on pause for a minute. I'm going to look at it, and I'll be right back with you.